Students, in previous lecture we discussed large sample test for difference of means. In today's lecture we are discussing large sample test for difference of standard deviation. Let's start test of significance, that is large sample test for the difference of standard deviation. Suppose we have two independent samples S1 and S2 are standard deviations of those two independent samples. Then under null hypothesis, as we have seen many times, under H0 sigma 1 and sigma 2, that is standard deviations of both large samples are equal, okay, don't differ significantly. So the static or standard normal variate Z is equals to, as we know, S1 minus S2, because it is actually x minus mu. In place of x we have difference of standard deviation may S1 minus S2 minus mu. Mu means mean of S1 minus S2. We have seen in last 2-3 cases it becomes 0 because sigma 1 equals to sigma 2, and sigma 1 and S1 are also taken equal, sigma 2 and S2 are also taken equal. So in that reference it becomes S1 minus S2 only in numerator, and denominator standard deviation of same, say S1 minus S2 for large sample. But in case of two samples, the SD standard deviation of the difference of sample standard means is, that is SD, that denominator is given by this formula. In case of large sample we have to use this formula, so we replace SD S1 minus S2 by this and we get final formula of Z. But we have to change only one thing. Usually these two are unknown, sigma 1 sigma 2, and we take them approximately equals to sample variance with S1 S2. So sigma 1 is replaced by S1, sigma 2 is replaced by S2. So that is the final formula for Z, which we will utilize for solving problems whenever we discuss test of significance for the difference of standard deviation. As you can see, the problem is given as random samples drawn from two countries gave the following data relating to the heights of adult males. Two countries A and B, standard deviations in inches are respectively given as 2.58, 2.50, number in samples 1000 and 1200. Is the difference between the standard deviations significant? And as nothing is written there, so as a standard tool we will use 5% level of significance for final confirmation of solution. As we are given N1 and N2 1000, 1200, S1 S2 standard deviations for country A and B 2.58, 2.50 inches. Under the null hypothesis H0 we assume that there is no significant difference between sample standard deviation, and then we use this formula of Z which we discussed in previous slide. As samples are large, so it's easy to use this, and SD, the denominator of that formula, is to be calculated, whose formula is given in this form. But sigma 1 and sigma 2, that is the standard deviations of the major population from which these samples are taken, are not given directly, so we assume that sigma 1 is S1 and sigma 2 equals to S2. So using these expressions, the final formula for SD of S1 minus S2 is there, and we substituted values in that formula to obtain its value 0.07746, and using this value and S1 minus S2 numerator, value of Z is finally calculated at 1.03, and it easily shows that mod Z less than 1.96, and at 5% level of significance we know that the threshold level is 1.96 and it's below that, mod Z is below that. So we say the null hypothesis is accepted at 5% level of significance, and the sample standard deviation do not differ significantly as what was asked to us. We are giving the solution that yes, it do not differ significantly. So that is about large sample test for difference of standard deviation.